height, and here the vertical component is 0, only the horizontal component there, only the horizontal component. Okay, and we also derived the time period for this. The time period t comes out to be under root of 2y upon g, under root of 2y upon g. This was the formula. Calculate the time period in the horizontal projectile motion. Okay, and range, and so like that we have already calculated that. Let's do some questions on this. Question is that the horizontal component of the velocity is equal to 50 upon 3 cos of 55 degree, cos of 53 degree, and that's equal to 50 upon 3 cos of 53 degree. I have value of cos of 53 degree, that is 3 upon 5. That's 3 upon 5. So that would give me 5 1 or 5 5 10 or 3 cancel here. So that will give me 10 meter per second, but along the ux. So this is ux, that is 10 meter per second. The displacement covered by this object will be, the displacement will be from here to here, right? So this displacement is actually the ux multiplied by t, x multiplied by t, right? Because this displacement, as we have studied about it, that the uh, uh, velocity is equal to displacement upon time, displacement upon time. So therefore displacement will be equal to velocity multiplied by time. So therefore velocity along the x component is ux, this one, ux, right? So I can parallel shift this here. So this is ux and multiply by t. So it will take time t to reach from here to here, multiply by t. That's why x equal to ux multiplied by t, right? So x is given, I think here. Just a second. Yeah. So x is given here. Let's suppose the displacement here is equal to 40. That is given in the question. I forgot to write it initially. 40 meter. So therefore we can calculate the time from here. That is 40 is equal to ux. So ux is 10 multiplied by t. So therefore which implies t is equal to seconds. Two bodies are thrown at an angle of 45 degrees. So one body, let's make a diagram of one body. For example, this is one body and this is the horizontal axis, and this body is thrown at an angle of 45 degree. So it will, let's suppose, follow this projectile, and the angle is 45 degree here. It's equal to 45 degree, and this will be its maximum height, h max, and this will be its initial velocity u, and theta is also given, right? And the second is thrown at 60 degree angle. So let's make this projectile. For example, this second body is thrown at 60 degree angle, and the projectile is this one. This will be its maximum height, this h maximum, and the angle is 60 degree. Consider that this is the 60 degree angle, and this is velocity, for example, u. Height here is equal to equal. That means this height h1, for example, if this is h1 height and this is h2 height, so therefore h1 will be equal to h2. That is given in the question, right? So now you can simply calculate the values. So you can use the height formula. Do you remember the maximum height formula?
It is u square sine square theta by 2g.
Exactly, u square sine square theta divided by, yeah. So theta here is 45 degrees. So I can simply write it as 45 degree is equal to square here, or let's consider that this one, uh, and sine square 60 degree divided by g. G gets cancelled from both the sides. So therefore we have u square sine square 45 degree, that's equal to 1 upon root 2 sine square Therefore, 1 upon root 2 whole square, because this is square, is equal to u square 1 square. This is u square sine square 60 degree, and sine 60 degrees under root by 2 root 3 by 2 square. So that's equal to, you can now calculate it very easily. That's equal to u1 square, uh, 1 square, and this is sine here. This is sine here. Sine gets cancelled on both sides. Yes, you can see sine it's cancelled. So this is 1 upon 2. 1 upon 2 is equal to square. This is 3 upon 4, right? 3 upon 4. So therefore, some cancellations here. 2 1 are 2 2 are. Therefore, u1 square is equal to u1 square divided by u2 square. Here I can bring this here. Is equal to 3 upon 2, right? 3 upon 2. Or if we take this square, both of these, for example, I can write it as u1 divided by u2 whole square is equal to 3 upon 2, or u1 by u2 is equal to under root of 3 upon. Okay, so this was the ratio of velocities. 1 by u2 equal to under root 3 by 2. Okay, let's do